Welcome to the Unit 0, Section 2 video on simplifying expressions. Let's talk about interpreting expressions. So, an expression is a mathematical phrase that contains operations, numbers, and/or variables. So your operations are addition, subtraction, multiplication, division, taking things to a power, that sort of thing. Numbers, of course, you know what numbers are, and variables are letters that take the place of a number. Okay, so say we don't know what some number is, we use a variable in its place until we can figure out what that number is. Most often we use x and y, but it can really be any letter. A numerical expression contains only numbers and operations, so here, no variables, while an algebraic expression contains at least one variable in it. Recall that the order of operations is a rule for simplifying an expression. The acronym used to help us remember the correct order of operations is PEMDAS, P-E-M-D-A-S, and we usually just say PEMDAS for short. Of course, if you need a way to remember it, just remembering each of the first letters here, you can use the phrase, "Please excuse my dear Aunt Sally." Now, it's very important to know, what does all of this mean? So the P stands for parentheses. We simplify the inside grouping symbols first. And if you have a fraction, you're going to group each side of the fraction. So you'll group the numerator and the denominator. They will be their own groups. Next, we have exponents. Simplify or evaluate any terms raised to power. So at this point, we've introduced two steps. If you're given an expression that has parentheses and exponents, you'll perform all the things in parentheses first, then you'll do the exponents. Then the next thing in the order is M and D. Those go together, that's multiplication and division. You're going to multiply and divide everything in the expression from left to right, and you'll do multiplication and division together, okay? You do not do all the multiplication first and then go back and do all the division. You multiply and divide from left to right. And the same holds true for addition and subtraction. After you've multiplied and divided everything, then you're going to add and subtract everything from left and right. Once you do all of these steps, you should be left with some value as your answer. So let's do some examples. We're going to simplify each expression by using the order of operations. Starting with A here, we know we want to perform the top and the bottom of the fraction independently, okay? So we're going to start with the bottom here. First thing we're going to do in the bottom is we're going to take our power, because powers come next. So 2 squared is going to give us 4, and then we're going to add the bottom. So 1 plus 4 is equal to 5. Then finally, we will perform our multiplication and division. So here we just have a division problem. 5 divided by 5 equals 1. Now you'll note here we did do the 1 plus 4 before we did any division. That's because when you have some expression on the top and the bottom of a fraction, you must perform the top and the bottom first, then do your division. Because it's essentially like putting the top in parentheses and the bottom in parentheses. Now moving on to B, we have 4 squared minus, in parentheses, 4 minus 2. So we are going to perform the parentheses first. 4 minus 2 gives us 2. Then we will take our power, 4 squared, which gives us 16. And then finally, 16 minus 2 gives us 14. In C, we have 2 expressions in parentheses, so we'll perform both of those first. Starting with the first parentheses, we've got 1 plus 6 gives us 7. So that gives us 7 plus 4 in the first parentheses. 6 minus 2 is in the second parentheses, so that's going to give us 6 minus 2, which is 4. Okay, now we've got to finish adding the first parentheses. 7 plus 4 is 11. And then finally, we can multiply 11 times 4, which is 44. In D, we need to perform everything in the numerator first. All we have is addition and subtraction, so we'll perform that left to right. 8 plus 3 is 11. 11 minus 5 gives us 6. And then 6 plus 6 gives us 12. 12 divided by 4 is 3. In example E here, we're going to start with the top and the bottom. So starting off in the top, we've got 8 minus 2 in parentheses. That's going to give us 6. Then we do our power in the bottom. 2 squared is going to give us 4. On the top, 6 times 2 gives us 12. On the bottom, 2 plus 4 gives us 6. And then finally, 12 divided by 6 gives us 2. And then in F here, we have 2 sets of parentheses, so we'll perform both of those first. 6 minus 3 is 3. 3 minus 3 is 0. So we've got 5 plus 3 squared minus 0. 3 squared is going to give us 9. And we can go ahead and drop that 0 on the end because anything minus 0 is whatever came before. And then 5 plus 9 is 14. Now let's talk about evaluating algebraic expressions. So an algebraic expression can have both variables and numbers. The numbers in front of the variables are called coefficients and are multiplied by the variable. If there is no number in front of the variable, the coefficient is understood to be 1. To evaluate an algebraic expression, substitute the values of the variables into the expression and then simplify using the order of operations. So you're going to substitute what you're told the variables are number-wise into that expression, and then you'll do it just like we did in this previous section. So in example 2, we're going to evaluate each expression using the given values. So in A, we're told that h is 3 and k is 5. So the first thing we're going to do is everywhere there is a k, we're going to put a 5, and everywhere there is an h, we are going to put a 3. And now we can evaluate it as normal. We'll start with the parentheses. 5 minus 3 gives us 2, and then 5 minus 2 gives us 3. In B, we're told that h is 4, j is 6, and k is 6. So the first thing to do is to substitute those items in. We're going to take care of the multiplication first. 4 times 6 is 24. And then 24 minus 6 gives us 18. All right, 4 more examples for you. In C, A is 1 and B is 5. So everywhere there's a A, we're going to put 1. Everywhere there's a B, we're going to put a 5. We're just substituting in the numbers for the letters. Now we're just going to add and subtract left to right. 5 minus 1 is 4, and 4 plus 5 gives us 9. In D, x is 2 and y is 4. We just substitute those in. 6 times 2 times 4. We multiply left to right. 6 times 2 is 12, and 12 times 4 gives us 48. In E, we're told that x is 4 and z is 1. So substitute everything in. Start with our parentheses. 4 plus 1 gives us 5. Now we're going to do powers. 5 squared is 25. And then we add 25 and 4 together make 29. And then finally in F here, we've got B is 4, C is 4. So we're going to put those 4s in place of our variables. And now we're going to multiply left to right here. 4 times 2 is 8. 8 times 4 gives us 32. And then 32 divided by 4 gives us 8. Two more examples here for you. X equals 5 and y equals 4 in example G. So we're going to substitute those values in. We'll start by taking care of the power. 4 squared is 16. And then we just add left to right. 16 plus 5 gives us 21. 21 plus 4 gives us 25. 25 plus 5 gives us 30. In H, we're told that J is 1, K is 4. So we're going to substitute those in. We're going to start with the parentheses, 1 plus 1 equals 2. Then we're going to take care of the power, 4 squared equals 16. Then we're going to multiply 16 times 2, which is 32. And then finally, 4 plus 32 gives us 36. Now that we've seen how to work with evaluating expressions, let's talk about like terms and how we can identify them. So, a term is a number, a variable, or the combination of a number and a variable. Terms are separated by an addition or subtraction sign. Like terms are terms with the same variables raised to the same power. If there is no power on the variable, it is understood to be 1. If there is no variable associated with the number, then it is called a constant. Constants are also like terms. So if you have a number just by itself, and then you have another term that's just a number by itself, those are like terms because neither of them have a variable on them. So in example 3, let's identify the coefficients, variables, exponents, and number of terms in each expression. So let's start with example A here. Well, our coefficient is the number in front of the variable. So our coefficient here is, and you got to be careful with this, it's not 3, it's -3. Okay? You've got to include the sign that precedes it. Our variable is x. Our exponent is 2. That's the power that we're raised to. So how many terms do we have here? Well, we have only one term. In B, we have two coefficients. In the first term, we have a coefficient of 6, and in the second one, our coefficient is 7. In both of the terms, our variables are x. Our exponents in both are 1, because if we have no power on our variable, then the exponent is understood to be 1. And then the number of terms, we've got 6x, and then we have 7x, separated by an addition sign. So we have 2 terms. For C, we have coefficients of 1, 3 for the 2 terms that have variables. 4 is not a coefficient here because there is no variable attached to it. So our coefficients are 1 and 3. It's understood to be 1 on that first term in front of the x squared because 1 times x squared is x squared. Our variables are x and x. Our exponents are 2 and 1. And the number of terms we have here are 3. We have x squared, 3x, and 4. In D, we have no coefficients, we have no variables, and we have no exponents. But we do have a term because a number in itself is a term. And our number of terms is 1, and that term is -1. In E, we have a coefficient of 4 in front of the x to the third, or we also call it x cubed. We have a variable of x, and we have an exponent of 3. But we do have 2 terms because the 2 on the end there is a constant, but it is also a term. And then finally in F, our coefficient is 5, our variable is x, our exponent is 7, and we have just 1 term. All right, in example 4, we're going to identify the like terms in the following expressions. Starting with example A, we have 2x squared plus 6x squared plus 5x plus 9. So to identify the like terms, we need to find terms that have the same variable with the same exponent. And the first 2 here are clearly what fit that bill. We've got 2x squared and 6x squared. So those are our like terms. In B, we have an a squared term, an a squared term, an a term, and an x term. So our like terms are the two a squared terms, 3a squared and negative 5a squared. Okay, you got to be careful because you have to include that negative that comes before the 5a squared. In C, we have xy, we have an x, we have another xy, and we have a y. So our xy terms are what are the same. So our like terms are 3xy and negative 7xy. In D, we have an r term, and then we have a constant and a constant. Our constant terms are like terms. They're both numbers. So our two like terms are 10 and negative 5. In E, we have an x squared y term, we have an xy squared term, we have a yx squared term, and we have an xy term. Now, at first glance, you would say none of those are the same, but you've got to look carefully because multiplication, it doesn't matter which way you multiply, it's going to give you the same thing. For example, 2 times 3 is 6, 3 times 2 is 6. If you flip it, you still get the same result. So let's take a closer look at these terms. The first term is x squared y. The third term is yx squared, but we can flip that and make it x squared y, and it would be the same thing. So our like terms here are 7x squared y and the 2yx squared. For F, we have an s cubed t squared, we have a t squared s, we have a t squared s cubed. Okay, so that one's already the same as the first one. We've got the s cubed and the t squared. We have an s squared t cubed, which is not the same, and then we have an s cubed t squared on the end. So we've got three like terms here. The first, the third, and the last term are all t squared, s cubed, or s cubed t squared, some variation of that. In G, we have x squared y, we have a y squared z, that's not the same. We have an x squared z, all right, that's not the same as the first two. We have a zy squared. Well, that's the same as the second term because we have zy squared is the same as y squared z. And then the last term has all three variables and nothing else has all three. So our like terms are the second and the fourth terms. And then finally on H here, we have PM, we have m squared p squared, we have MP. MP is the same as PM, so those are like terms, the first and the third. And it looks like nothing else is the same. So our like terms are PM and 7MP. Now let's talk about writing algebraic expressions. Expressions can be written with constants and variables, or they may be described in words. When given an expression in words, it is important to be able to translate the words into algebraic terms. So there are several key words that indicate a particular operation is being used. So part of the challenge that a lot of people get in doing word problems is being able to interpret what the word problem is saying. So we're going to kind of start building on those skills of being able to interpret what a word problem is trying to say. So let's talk about keywords for the four operations: addition, subtraction, multiplication, and division. Starting with addition, we have several that you want to be looking for. First is added to. Okay, that makes sense, fairly straightforward. Plus, that's the term that we use for the operation itself, like 2 plus 4. The sum, which is the result of two numbers being added. And more than. Okay, so like 6 more than 4 is 10. Okay, we added that 6 to the 4 to get the 10. 6 more than 4 is 10. Okay. In subtraction, we've got quite a few terms here. We have subtracted from. We have minus. We have difference, because the difference of two numbers is the result of two numbers being subtracted. We have less than, works the same way as more than here. We have take away. So, for example, 8 take away 3 is 5. You have 8 to start, you take away 3, you're left with 5. And then taken from, very similar to take away here. In multiplication, we have times, which is what we call the operation itself. We have multiplied by. We have product of, because remember, the result of two numbers being multiplied is the product. And groups of, okay, because multiplication, groups of 3, you're multiplying by 3. In division, we have divided by. We have divided into, okay. So let's talk about the difference between those two. If we have, for example, 10 divided by 5, then we do 10 divided by 5, that gives us 2. Now, if we say, what is 5 divided into 10? You see how we flip the numbers? That's still going to give us 2. 5 goes into 10 2 times. We have the quotient of, which is, quotient is the term for the result of a division problem. And we also have ratio of, okay? We've talked about this before, where a ratio is like a fraction, and a fraction is simply a division problem. To translate verbal expressions into algebraic expressions, you want to identify the operation being performed, identify the values for the operations, and then determine the order that the operations need to be performed in. Okay? So, let's do some examples of this. We're going to write the verbal expression as an algebraic expression. So here we're just going to translate. The quotient of 32 and x. Okay, so if you want the quotient of 32 and x, that is a division problem. The word quotient tells us that, and it's going to be 32 divided by x. And we can write it in fraction form like this. The sum of x and 12 is simply x plus 12. 19 decreased by n. So decreased by n means that we are removing n from 19. So that's 19 minus n. 14 more than the difference of x and y. Okay, so now we've got a couple of things going here. So we're going to start with the difference of x and y. The difference of x and y is going to be x minus y. And then we're going to add 14 to it because we want 14 more than that difference. And it's important here to use parentheses around the x and y terms here because we are performing that operation before we add the 14 to it. The sum of 6 multiplied by a and 8 multiplied by b. Okay, so 6 multiplied by a is 6a. 8 multiplied by b is 8b. And we're going to take the sum of those two things. So that gives us 6a plus 8b. The quotient of m and 7 decreased by 10. So the quotient of m and 7 is m divided by 7, and then we subtract 10 from it. Twice x, that's simply 2 times x, so 2x. Half of u is simply 1/2 u, or u over 2. 5 less than 3 times x, okay? So we're going to do 3 times x, that's 3x, and then we're going to subtract 5 from it. So we have 3x minus 5. 7 times a number increased by 4. So 7 times a number, we can pick whatever variable we want for that. So 7 times whatever variable you choose. Increased by 4, we're going to add 4 to the end of it. So 7x plus 4. Or any letter of your choosing, any variable of your choosing. 6 decreased by 5 times a number, okay? So here we are decreasing 6 by what follows. So it's going to be 6 minus something. It's going to be 6 minus 5 times a number, 5x, 6 minus 5x. And then finally, 3 plus the product of x and 5. So the product of x and 5 is 5x, and then you're going to do 3 added to that, so it's 3 plus 5x. One quick note here, I told you in J and K that you have the option of using the variable of your choice. I just want to briefly mention here that there are certain letters you may not want to use as variables, such as L, because a lowercase l looks very much like the number 1. So you may want to avoid using L. You may want to avoid using T, especially if you don't write it with a curl on the bottom, because that's going to look very much like a plus sign. An S also you may want to avoid because it may end up looking like a 5. So there are certain letters that look like numbers or operations that you may want to avoid using. Another good example of this is O. You may not want to use the letter O as a variable because you may confuse it for a 0. So just something to think about here as you choose variables when there's not a specific variable listed for you to use here. Of course, X is always a very safe variable to go with. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.